Yeah, guys, in this session, I will talk about like a way these data engineers and data analysts and this machine learning people, so be business analysts, they will where this the people collecting the data and they're doing their daily work. So before that, like you heard, like in IT industry, there are different job roles to be there. So we have like front end developers, we have back end developers, we have database admins, or cloud. You can think like cloud admins, DevOps engineers, full stack developer, data engineer. These are the different job roles in IT industry. So, like which role we play, what things I will jump into the one by one. So think like I'm taking one use case, like think that is like a Netflix. Before coming to Netflix company will coming and asking one of the company like, hey, I need this kind of platform I want to build, and finally this is my business I want to run. Please do it for me. Like that, like Netflix company approaching one of the company. Think it is like something like TCS, any MNC companies. So they start the building. So for building end-to-end applications, TCS hiring these many developers, like the need for doing complete to design that complete product, they need different developers, like front end for UI purpose. Like they will UI means daily, like on our mobile or on website, you are seeing like on a UI part, right? Like username, passwords, and you will see the movies scrolling, and this all UI part. These things they will develop by these front end developers. That what we are seeing with our eye. That is called the visualization part. They will design with front-end developers. The front-end developers, again, there are different technologies they will came to picture, like their HTML, CSS, Angular, JS, React, and JavaScript. These people they involve, and they will design this UI part. But when come to this business logic, like fetching the data from the database, those things, and storing. When I suppose I'm the new customer today, I'm logging to the Netflix and I'm sharing my details, like first name, last name, and enrolling to account today. So this information backend, the Netflix guys, they will store in the backend. So how to store, how this kind of business logic, suppose tomorrow I'm logging, they're checking the credentials, they are they're checking my data. How they're checking my data, those all details, they internally, this like Java people, like backend people, like a Java team or Python team, they will use this some technologies like Spring or Django, this frameworks. They build that, like, they will be working like in the immediately for like UI part and the database admin part. So to how to connect those database, and how to show what triggers to show, this all internet, the business law, the main code business logic written by these people only, this backend developers. So what is the goal of this data admin people, right? So think like Netflix will not store an entire data in a single table. They will be split the data into multiple tables. If you store the data in a single table, it is high in, like it's like you can see there is like a lot of columns will be coming out, and a lot of records will be generated. For doing some analysis, some particular tables, that is not easy case. So for better purpose, they will be designing individual tables with different. They will categorize according to the categorization. They will create a different tables. So that those creating those tables and managing those tables, and thus managing the databases and giving access for particular tables to particular people, those things will maintain this by this database admin by, whether it will be cloud admin or on-premises database admins. These people, they will work in this kind of area. Coming to the DevOps engineer, like TCS may have, taking example like a TCS company, to building this product. TCS may acquire 100 people, to hire 100 people to complete this project. But they will, like they take like 50 employees as a Java developer, 10 employees into one team. So every team, they will work on some business logic, and they will be like they're pushing their code into Git. So like that, there are different develop like 50 developers are working, 50 developers are merging their code into their GitHub environment. So after that, uh, we need to deploy into production. Like, who will take care this kind of, like, once say code is the development, and who will take care of it? This DevOps senior team will came to picture, and they will take care of deployment part, like any kind of checks, like any like in test cases and so on of checks, Jenkins, they will use like Docker. These are the some of the tools they will use it in daily life as a DevOps engineer. And this, like, deployment button is not responsibility. Most of the things not responsibility by who are developing. They will give, like, even though you are TL, like even though you are experienced person, 10 to 15 years of experience persons also, for every team they have like a DevOps engineer team is there. This team will take care of like deployment for and managing server. Suppose Netflix today also every second is keep on line running. It may be any crashes, like something like server is coming down, something is not, some service is going down. So those things will take up by DevOps engineers, and they will be restarting that servers, which is servers failing. Those internally, this DevOps engineers, this kind of people will head to the business. Coming to the full stack developer. So full stack developer means who knows front end development like Angular JS, React JS, who knows Java also, like Spring Boot, this all, who knows like SQLs, like how to create how to manage database. Those people like who knows everything, like this all, you can say this all four points. Who knows this all full technologies, those people, so you can call as a full stack developer. They're expert in all areas. So some companies they're expecting their employee will be good on all areas. Like small companies, mostly they prefer full stack developers. This all that means everything will they only doing, and that is a scenario. And coming to the data engineers, data engineer or data analyst or machine learning guys or business analyst. So, front-end developer designing UI part, and back-end developer designing business core logic, and how to store this data and daily data, users data and all. And whatever the data is available in this databases, either SQL or any table like that, these people will load this data, like data is a data list, will start analyzing and will start finding the insights, and they will do predictions by using this data. So that means first, without these four peoples, these people don't have work. Once the product is completed, when the application is running, then only we can get the data from the user side. Whatever the data collected from the user, and on that data, we are start analyzing for, you can see, like to recommend, if you want this, like any place guys want to recommend the good to the movies to the user, because of they want to improve the customers, or customers like need to watch more time. So in that way they will get some ads amount like that. So for that they are trying to build some recommendation engine, or else they want to understand like the how the business is going and all. So for to understand this business, understand this recommend to build the recommendation engine, or to know this all these things, these people help to the Netflix guys, and they will take, and they will change their business according to this like business insights. And on the other, if any changes required in UI side, again they requested to the UI developer, they will change some UI part and stuff. Again, whatever the changes with these changes, they will be deployed their patches and continue the business like that. This every company will keep on, it will recycling the already developed, coming to the new patches kind of work will be there. So that's why I told, like here, like every role will play important role. If front end developer is not there, means back end developer is not there. So It is something like side, each role we depend on each other. If these people not there means, this might be the Netflix guys, they will not get a good profit in terms of business. They will lose the business, they will shut down the business. We don't have any work for all developers. So that is a scenario. So these people, mostly they will talk about in terms of business. These people will talk about how to run the business in a technical way. Coming to the next slide, yeah, how data is generated. So I told here, wait a second. Fine. Coming to here, like suppose this data engineer, data analyst guys, machine learning, they need data, some data to start analyzing. So how that getting data means, this is how. So suppose as I told earlier, there is a new user registration, like we are giving ourselves, we are giving name, only mobile address, like some purchasing this transaction status, something like purchasing some Netflix amount, like a 1 month or 6 months kind of data, and we are giving the reviews per particular movie, kind of like click things, like when scroll down thing, like what we are searching and in the search bar, and what which item we are clicking, how much time we are spending on that Netflix, and streaming logs, that which movie you are watching, like how many times what you are skipping, when you are passed on the video, like this all information is we don't know, but we are just sitting by our home, we are just clicking this whole thing. We don't know, the Netflix guys, we store each and every information. It means each and every event they will store into databases. For what they will do, for while using that information, they do analysis, they will build recommendation engine, they will give some suggestions, they will give some product selling in better way. This all this information, on top of this information, they're doing this all such things to develop their business. Something like, see, the data will come something like they go they install into logs, either JSON or this formats. Coming to the next line, where this data will go. Suppose if the data is coming in a structured format, companies will choose this kind of RDBMS, like MySQL, Postgres, in the these things. If data is coming like a semi-structured data, think like we are building Netflix streaming application. In that case, we store the data on live data. We're storing, either we will use Kafka or there else we will use Kinesis. This is a public, this is a like messaging systems. They will be something like consumer and producer approach they will follow. Publish and the substrate kind of things. So if the data is in a if it is data and unstructured, those things, semi-structured, those things, this data will not store. See, RDBMS expectation will be the data will be in the structured format. Then only this database will support to store the data. So if your data is in live, if data is not coming with a semester, like unstructured data means, either we use for temporary, like 1 day, for temporary case we will use Kafka Kinesis, and for permanent storage we need to use S3 as a S3 buckets or HDBase locations or a data lake. From here, once we are storing any Kafka, either Kinesis and her, here the data years will involve and clean the unstructured data and make them transforming into proper structure and proper way. These things will done by data engineers. And whatever the cleaning data, whatever the things we are doing, this output data, this like data engineers output data will taken as an input to this analyst or data scientist guys. On this cleared data, they will train the model, they will predict the analysis. This is the flow will happen. See, first, for doing this data engineering cleanup activities and transforming the data, this part I'm talking about. So we have number of options in a market, like In Excel also we can do analysis. With via SQL also we can do same analysis, data analysis. Hadoop also support data analysis. Snowflake also support. Spark also support. But each tool they have one problem. See, for simple, see Excel file, if I'm not run more than like 10 million records or 50 million or something like that, they know some limit. After those many records, it will not handle this Excel. So this is like less, we can say less storage. There is for simple storage, we can use with Excel as a tool for doing analysis. And coming to the SQL, when the data is only structured format, then only you can do analysis with the SQL queries, but it is slow compared to some other technologies like the can do something join operations and all. It will be slow because of it. Mostly it will work on any kind of like a single node structure. It will not work on kind of like a cluster. When come to this Hadoop also, we can also use Hadoop for analysis, data analysis, data cleanup, and for this kind of activities. So the problem is Hadoop will support only batch processing. That means streaming water to live data, like a Twitter data on live data. This data for doing analysis purpose, Hadoop may not support. It will be supporting only batch processing. That means only historical data which is happened, you can say yesterday from John first to yesterday. For this data, first doing some analysis, this Hadoop is support. But compared to the some other tools that comes to us like Spark and Snowflake, it is slow because of it is following some disk-based approach while processing the data. That means the intermediate results will store the into disk. It will not maintain any kind of like in memory, and the intervals will not maintain in memory in the RAM itself. So that's one of the reason we are skipping Hadoop here. And come to the Snowflake. Snowflake's also used for this is also data warehousing technique. That design is for data warehouse techniques. But it is not open source. It is expensive. We need to pay some amount. We can limit it for machine learning algorithms. We cannot pull more machine learning. I mean, would love that much good at machine learning models. When come to the Spark have their own features. It will support both batch processing. Tail time means live data. Also, we can fetch the live data within fraction of seconds. We can start analysis and live. We can give it that's live data to downstream applications like ML people and ML engineers. The ML engineers within a fraction of seconds they will pull this Spark data and they will predict the results. Predict the results. So this all things will happen in a fraction of seconds. And as I told, the features of Apache Spark, it is open source. No need to pay anything. Like Snowflake, we need to pay some amount. In not even databases also, we need to pay amount for using those tools. It handles large data, large scale patches and like real time. This kind of data will handle. Supports SQL, Python, Scala. These are the 4 languages Spark will support. But when go to this Hadoop, it will support only Java. It will not. We cannot write Hadoop code. I mean, Napd. Talking about Hadoop means Napd. See here, Hadoop. In Hadoop ecosystem, we have like HDFS and MapReduce. We call them. So for the Hadoop HDFS is used for storing purpose, and then MapReduce is used for processing. So how to process, how to clean this, so whatever the data is coming, those things we need to write the piece of logic only in Java. It will not support Python or Scala and some other languages. But when come to this Apache Spark will support either you can write the code to how to transform the data, how to clean the particular data, whatever the data you are receiving from the web applications via Kafka or Kinesis. To dealing that data, we can write in scheme queries, we can write with like Python code, we can deal with Scala, or else we can deal with Java also. This Spark will knows all these four languages. Coming to the model support. See, Hadoop will support not only for batch support, but it will support, it has libraries like streaming library, it have SQL libraries, it have machine learning library, it have graphics. So, I mean, Spark ML with by using Spark ML, we can do models productions, model deployment, model training. No need to go that different, like a, separately we moving to train the machining algorithms by using Jupyter, some other libraries. Internally, Spark will support that integration. See, compared to the Hadoop, Spark will be much faster because of the one of the key reason is in memory. But Hadoop will not have this feature, in-memory feature. Because of we don't have in-memory feature, it will be writing the intermediate results into a disk. See, when we are writing the results into the disk, that means we're using some network IO calls. See, when you are transferring your data via network, it will be a costly operations to stuffing data from the disk to our processing area. So because of that button shuffling data from here and there, that will take time. So that's why Hadoop jobs will run slow compared to the Spark jobs. Coming to the next slide, and real time what happens, like suppose most of the things I already covered. When user clicks the video, web application will generate the log files for event. Like a click stream sending to this events will send to either Kafka or Kinesis. This will be from here. They will store another like Kafka topic or any streaming. So from this Spark will particular from particular topic Spark streaming will read that events information to the Spark area and clean this information, and sometimes we need to enrich the data. Suppose enrichment something like suppose the log it is events will happen. With the log event you have something like a IP address and all. We don't have much information about the user. So by using this log information, with IP address, one of the column might be like a IP address. By using this IP address, we need to track which location it will, like which country it will be. So Netflix users might be throughout the world. Like they need to understand like which user is like he's from which city, which country. So those tracking information we can get it back with the IP address. We need to look up with we need to use some lookup tables. By referring this IP address, we will fetch some information like which country he is and which city. Like suppose like India, and he is belongs to some Hyderabad location. This information we need to fetch like on live data. This the on the top of the raw data, we will adding some extra information. Where we are getting this extra information means from the lookup data. How we are getting this lookup data means by using IP address. See, in Spark, we are doing this kind of enrichment by taking the help of enrichment. We are doing here. Once the enrichment happen, we are giving this information again. We are storing Spark again. Will send this enrichment once this step is completed. This will store this information again, sending back to the Kinesis or Kafka topics. Whatever the information, whatever the enrichment we are doing, this data will be taken by ML engineers. These ML engineers will start doing, they will do analysis, they will, whatever the internal of the models, they design the code. According to that, this will predict the results and giving some recommendations, something like that. Coming to the next slide, what happens if you are not cleaning the data? What happens? What is data cleaning and streaming? Suppose you are getting data on live streaming data nulls values. There is no fixed some skin mismatches. You are getting some nulls. You are getting suppose some you will face some timestamp issues like something like UTC, something like GMT time. So like India will follow some different time, and realistic people will follow different timings. There is something like milliseconds. There is a, if you see that time we're using lengthy information like 00 something 1 2 3 something like lengthy information. This is not like that much so helpful while doing some insights. So we need to convert this kind of data. So how we're connecting with by using Spark, those things we're converting. See, here like sparse streaming means it's not like every second we are doing, within every second we are reading and doing. Like it is something like the some narrow gap will be there, like for processing might be take 2 seconds, 5 seconds to complete this, whatever, like removing the nulls, fixing the schema, these things will be happen. See, finally, ML team or ML engineer or ML model, it expects the data should be clean. If data is not clean, it will predict the wrong results, or else some models will not support the null values. It will some machine models will throw error. So for that, we need to follow some imputation. We need to write some imputation logic, either some theta mean or mode, applying some unknown value, filling some unknown value. In Spark, we are doing something like we are applying something filling, and if it is any records coming with null, so please fill this information with this information. So such kind of operations we need to do with Spark. This is how like handling nulls in live ML productions. Not see from the web application. I mean Netflix. Once the user clicks the information, it will come to the Kafka. Come from Kafka, we're using the Spark streaming. Spark streaming here, what we are doing, removing nulls, enrichment, we are doing. Once this enrichment, everything is happened, we are giving this data to ML teams. This entire information from here to web application, from the user, from the Kafka Spark, from L, and then it will take only, see, we need to complete this operation something like within 5 seconds. See, generally in ML model, for doing some EDA step, it will take lot of time, 1 week or 2 weeks of time. So if you start doing some EDA on this live data, whatever the data is coming from the here, from the Netflix live data, that is meaningless. You can't predict the results within the on live, like within, we cannot take action on the live. Like suppose if you are watching YouTube videos, within another 1 or 2 minutes, it will show the recommendation in the similar product. Like suppose you are watching movies like a English movie, the next minute the YouTube recommendation was he knows English, he knows he like this kind of action movies, so will recommend this action movies only for this person. This kind of actions we cannot take immediately. If you start doing EDA a step like within we have like 10 days or 15 days of time. So for that we need to do coding part in EDA step. Like you went at my modeling time, you need to write a snippet of code. When we're getting something like for this on top of this data, if we are getting something missing values here, fill my missing values with more mean value or median, those value, those imputation things we need to do. Or else if any rows which is more like null values, in this case also remove the particular record itself. You don't to give that record to my model, or else encode the unknown categories. If any category is not, it is coming something black, or I mean you are using something like unknown, say something like Most of the cleaning activities and this enrichment, everything will be done by Spark. Still, some areas that some dry areas will be there. Those areas will be written by ML minutes in the EDA step. See, finally, before giving to the ML machine learning models, our data should be clean and very clear. Then only this model will take this data and will start analyzing and start prediction and give the and live itself give the recommendations. The summary of the like you can see like what I explained from from all PPTs. Like after generating the data, may it be the structured and unstructured that we can call as a quick stream, considering like Netflix. And the streaming data, whether we can store it in databases or we can those logs or data we can use it in any data lake or S3 or any SQL database or those things. Either we can use it here. And whatever the storage information, on top of the storage information, we need to do some analysis. For this analysis, we use a Spark. We're choosing a Spark as an option here. So we're reading the data into Spark environment. We're cleaning the data. We're enriching the data in the live, and then give it into this live data into like ML models. ML models will make predictions. This all entire work from UI to from UI to ML prediction. You happen within the seconds. Might be 5 seconds, might be 10 seconds. It will take time. Here, for entire flow to make success this job, because of front-end developer, because of Java team, or because of database admin team, or because of you can say data engineer team. In here, engineer team means like we're using a Spark as a engineer team here, Spark people. These all people will help to predict the machine learning in a perfect way. This is how real-time the applications will work and each thing is doing in what. I hope you will have some better idea on that. In coming sessions, I will focus more on Spark and uh, like a machine learning area. So my key area is working on data engineering side and sometimes in machine learning part. So I hope you understand this section. Thank you.